Here's our second input-output table. Notice again we have three values for x. We're going to take these values one by one and substitute it in for our x value. We're going to record our work here. With each one, we're going to get an output, which is going to equal y. So here we go with the first one. Whoops. Let's go back here. There we go. Let's start with the first one. Here, I have 1, and I'm going to subtract 1. I simply took the value for x and substituted, and we know 1 minus 1 is 0. Next, I have 4. So this time, x equals 4. And 4 minus 1, our output is 3. And finally, 8. 8 is substituted in for x. 8 minus 1, and we know the output is 7. Here is input-output number 3. Notice again, we have 3 inputs. We're going to substitute each of these in for our x value. But notice, our expression looks a little bit different, and we have 3 times x plus 2. So that means whatever value we get for x, we're going to multiply it by 3 and then add 2. And this will give us our output, or our y value. Let's try the first one. Here we have 3. We're going to multiply it by 0 and add 2. And we know that 3 times 0 is 0, plus 2, our y value is 2. Next, our x value is 2. So this time, we substitute the 2 in for x. Notice I'm using parentheses. So it's 3 times 2 plus 2. Well, 3 times 2 is 6. Plus 2 is 8. And finally, 4. I substitute the 4 in for x. So it's 3 times 4 plus 2. I know that 3 times 4 is 12. Plus 2 is 14. Notice the pattern. Each time, what did I add to my y values? Turn and talk. See what you can come up with. Here is input-output number 4. Here, again, we have 3 inputs. Notice this time, our expression we're dividing. So whatever value we have for x, we're going to divide it by 2. And that's going to give us an output, which is our y value. Let's substitute. My goodness, why does it keep doing that to us? So here, there it is. We have 4 divided by 2. Well, we know 4 divided by 2 is 2. Now, notice how I changed to show my division. This time, x equals 8. And it's 8 divided by 2. I used a fraction bar. And 8 divided by 2 is 4. Finally, 10. 10 divided by 2. 10 divided by 2 is 5. Here we go with input-output table number 5. Notice this time, they did not give us any x values. Next, we have our expression x divided by 4, and this time we have our outputs. So when we see this, the key thing that we want to do is work backward. And by working backwards, we're going to be able to come up with an x value. This one takes a little bit longer with a little bit of extra work, but we can do this. The first example, notice I have no x value. Here, I have x divided by 4 equals 1. I'm going to write that down. X divided by 4 equals 1. As we can recall, whole numbers have a denominator of 1. So all I need to do is cross multiply. And when I do, I get 1x, or just x, equals 4 times 1, which is 4. So now I just divide by 1, x equals 4. And now I can fill it in. 4 divided by 4. Let's check it. Does 4 divided by 4, does that equal 1? Yes, it does. On the next one, let's change colors. I'm going to go back to red here. Here, I have the value of 2, and I'm going to set it up exactly the same way. But instead of my expression equaling 1, it's going to now equal 2. So I have x divided by 4 equals 2. Remember, every whole number has a denominator of 1. Now, I can cross multiply. Let me put those arrows on there for us. Here, I have 1x, or just x. And what does x equal? 4 times 2, which is 8. So, 8 divided by 4. Notice I used 8 in for x, not the 2. That's one of the greatest mistakes kids make. Please be careful. Finally, here my y value equals 4. I'm going to change colors one more time. This way I can kind of differentiate between the input-output work that I'm doing. This time, all of my stuff is going to equal 4. Well, here I continue to use x divided by 4. X divided by 4. Remember, every whole number has a denominator of 1. Now all I have to do is cross multiply because I have a proportion. Here I have 1x, or simply x. And x is 4 times 4, which is 16. So here I have 16 divided by 4, and that does in fact equal 4. Here again, I have an input-output table, this time number 6. Notice no x values, but I do have my y values. So again, we're going to work backward. So to do this, I'm going to start with something equaling 1. Well, what equals 1? Whatever x is divided by 2. X divided by 2. Remember, every whole number has a denominator of 1, and now I simply cross multiply. 1x, or x, equals 2. And I have 2 divided by 2, and that does equal 1. Let's change colors so we can let it pop out a little bit. This time, something equals 3 because I'm right here. Well, what equals 3? X divided by 2 equals 3. But here, all we need to remember is that every whole number has a denominator of 1, and because it's a proportion, I simply cross multiply, and I'm left with 1x, or x as we now know it. That equals 6. So I record the 6, and then I question, does 6 divided by 2, does it equal 3? Yes, it does. It does equal 3. And finally, something equals 5. I'm right here. Well, what equals 5? Whatever x is divided by 2. X divided by 2. Because every whole number has a denominator of 1, I create a proportion, and I can cross multiply. 1x, or x, equals 2 times 5. 2 times 5 equals 10. So this time, 10 divided by 2. Does 10 divided by 2 equal 5? Yes, it does.